So I want to look at this problem. So if you need to, you can take a moment and pause the video if you want to read the whole thing. Otherwise, you can just go along with me. So when you look at this problem, sorry, shifting. So when we look at this problem, what you can see is that we have things already in a beaker. So let's go ahead and draw our beaker. And we already have silver in here and barium in here. Yes, there's also nitrate in here, that too. Now, what's going to happen though is we're going to add in chromate. And yes, it is technically potassium chromate. But what's going to happen is we have the potential to form either silver chromate or barium chromate. If we added enough of our potassium chromate, we could certainly form both, but we want to know which one forms first. So because we already have a certain amount of silver and a certain amount of barium, those 0.2 molar of each, that's not going to change. So we have a certain amount of silver and we have a certain amount of barium. What we can change is we can change the amount of chromate. So what we're going to do is we're going to solve for the amount of chromate needed in order to make either one of these precipitate. To do so, we're going to look at the KSP expressions. So my silver would give me 2 silvers plus 1 chromate. My barium would give me 1 barium and 1 chromate. So when I look at my KSP expressions for my silver, I would have KSP would be equal to my silver concentration all squared times my chromate. And I know from the problem it gave me the KSP value for my silver, which is 1.2 times 10 to the negative 12. Now, again, from the problem, I already know the amount of silver that I have. So I have 0.2 molar silver. That's what I have. So I want to know how much chromate I need to add in order to just begin precipitation. Now I realize that this equilibrium value is technically where there's no precipitation, but realize that if we just went slightly more, we would get it to precipitate. So we are going to just go ahead and use our KSP expression to give us that value. So this is also 0.04 times my amount of chromate equals my KSP expression. So I can divide both sides by 0.04. And I get a value of chromate needed to precipitate of 3.0 times 10 to the negative 11. So if I wanted to precipitate silver, I would need this amount of chromate. So now I'm going to do the same thing, but for barium. So I already have my barium expression. So now I'm going to do the same general idea where I can look up the KSP for my barium chromate. So there's my barium. There's my chromate. I have a KSP value for that. I guess I need to move my page so I can look at what it is. 1.2 times 10 to the negative 10. The amount of barium is still this 0.2. It's not squared from the KSP expression. So this time I just have to divide. And I get a chromate concentration of 6 times 10 to the negative 10. So that's the amount of chromate I need to precipitate barium. So then I can look at my two values, and what I see is it takes less chromate to precipitate the silver. So this is the amount of chromate I need to precipitate barium, 6 times 10 to the negative 10. There's the amount I need to precipitate the silver. I need less chromate to precipitate silver. So since I'm adding in chromate little bit by little bit, I'm going to add enough to precipitate the silver first, because I basically add this a little bit at a time. So I'm going to reach this smaller number first. So then when I want to go ahead and look and see how I did on my answer choices, I should get silver and 3 times 10 to the negative 11.